Okay, in this lesson, we're going to talk about slope of a line, the slope of a line, and also how that slope relates to the rate of change. All right. So first of all, to define the slope of a line is that a slope of a line is just a measure of how steep a line is, and is written as the ratio of the rise to run. And so oftentimes we'll say slope is equal to rise over run. Well, and to find the slope, basically what we're going to do is we're going to find 2 points. All right, so that we know the coordinates of, and then we just say we have to move in either straight up and down or and straight left and right. So we count how many spaces we go up and how many spaces we go over. So going up is a positive slope, or is a positive rise. If we would go down, it would be a negative rise. Okay. And then going to the right is a positive run. If we would go left, it's a negative run. Now, if we look at the line in general, like in this case, if we look at this line looking from left to right, we can see that this line goes up. All right, so if that line goes up, that means it has a positive slope. In this case here, the line going from left to right, the line goes down. So that is a negative slope. All right. Now, this says find the slope of the line. All right, so to find the slope of the line, we're going to just simply pick 2 points on the line, and we're going to write it as rise or run. So let's pick this point right here and this point right here. All right, so we're going to remember we're going to write it as rise over run. All right, so if we look at this, the rise would be 1, 2. So rise is 2, and our run is 1, 2. So the rise over run is 2 over 2, which 2 over 2 we all know is the same thing as 1. So this particular line has a slope of positive 1, and we can verify that it's positive because it goes up as we're going left to right. Okay? Find the slope of this line. Well, we've already got 2 points that have been picked for us, right here and right here. Okay, so we're going to say rise over run. So we're going to rise, and it's going to go 1, 2, 3, and we went down. So that's going to be -3. And then our run is 1, 2, 3, 4. Now, it's important to notice here that we're counting the spaces. We're not counting the lines. We're counting the spaces. So it's -3 over 4, or that could just be written as a slope of -3/4. All right. Well, this is interesting because we have a line that just goes straight across. Well, once again, rise over run. So if we pick 2 points from here to here, all right. So if we go from here to here, how far up or down do we go? Well, we don't go up or down at all. So our rise is 0 and our run is 3. Okay? So 0 over 3, or 0 divided by 3, is just plain 0. So that tells us that anytime we have a horizontal line, or a line that goes all the way across, that's going to have a slope of 0. Okay? So a horizontal line has a slope of 0. Okay? And I might come back to that in just a minute. Yes, I'm going to come back to that. If we have another line, say a line that goes straight up or down, okay, like this, okay, like that blue line, that is a vertical line and it has no slope. So a vertical line, we say, has an undefined slope. Okay. And basically what that means is that there is no slope for a vertical line. And because we have a number that goes up or down and a zero in the denominator, and we cannot have anything that has a zero have a ratio with a zero in the denominator. Okay, so a vertical line has an undefined slope. All right, here it says graph the line. So now here we're going the opposite direction. We're given the slope and a point, and we have to draw the line. So it says graph the line that has a slope of negative 3/4, okay, and passes through the point negative 3/2. So negative 3/2 has 1, 2, 3, 1, 2. So right here, that's the point, this point negative 3/2, okay, and it says the slope is negative 3/4. So that means that, and let me just get a slightly different color here, okay? That means that we're going to go down 3. So we're going to go 1, 2, 3, and then to the right 4. 1, 2, 3, 4, and we end up right here, and that's where we draw our second line. If we want to do it again, we can, but two of them is going to be enough, because all you need is 2 lines or 2 points to draw a line, and then you just draw a line through both of those points, just like that. Okay, and you draw the line all the way through the points. Okay, draw a line all the way through the points. You don't stop at each point. You go all the way through them. Okay. All right. So here it says graph the line that has a slope of 3 and passes through the point negative 1, negative 2. So negative 1, negative 2 is this point right down here. Okay. Now it says it has a slope is equal to negative 3. And remember that if we have a whole number, we need to write that as a fraction or a ratio. We can write it as negative 3/1. Okay, so what that does is we can go 1, 2, 3, and over 1. Draw a dot. Go 1, 2, 3, and over 1. Draw another dot. Okay, so now we have, in this case, I drew 3 dots. Okay, and a lot of times I'll say draw 3 dots. That way you can make sure that you didn't just make a careless error. Okay, and see if I can freehand draw this. Nope. Let me get just a straight line here. Okay, and that takes us all the way up through there, and there we go. Okay, so that's that line there. All right, so the ratio of 2 quantities that change, such as slope, is a rate of change. A constant rate of change means that it's changing at the same amount over time. Okay, so a constant rate of change is shown as just a straight line because it doesn't change at all. This is a constant rate of decrease. In other words, whatever it is getting smaller over time. A variable rate of change changes. Okay, so that's going to be a curved line. It's a variable rate of change because it may drop really fast, and then all of a sudden it'll get to the bottom and it'll start increasing again. Okay, so there's different scenarios of that happening. A constant rate of change is like if you're emptying a sink full of water. All right, you pull the plug and that water drains out at a fairly constant rate of change until the sink is empty. All right, a variable rate of change is if you're in a car, for instance, and you come up to a stop sign, you're going fast, and you slow down until you stop at the stop sign, and then you speed up again to get going. So you're going fast and you slow down until you stop, and then you go back up again. And we had talked about this in the previous lesson where we talked about interpreting graphs. Okay, this is the same type of thing. All right, so does this graph here show a constant rate of change or a variable rate of change? Well, we notice here that it is a curved line. So if it's a curved line, that means it's a variable rate of change. All right. In this one, it's a horizontal line. It says flat as can be, but it's straight. So it's a constant rate of change. And the unique thing about this is that there is no change. Okay, that's the interesting thing about this is that this really has no change at all. And there are many scenarios where that's the case. All right. This right here is a straight line that goes up. So this is a constant rate of change, and it's what we would say a constant rate of increase because it's going up. And this is a variable rate of change. This is a variable rate of change, all right, because it goes up, 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 up until it gets up to this point, and then all of a sudden it starts decreasing again. So it's a variable rate of change, all right? So variable. All right, so that is it for this lesson. If you have any questions, make sure you ask. Make sure that you've copied down all the notes that we have up at the beginning of the lesson before we started the examples. And we'll talk to y'all later on.